So I'd start again. This is polymorphism, and so the OOP concepts uh, go like this: polymorphism, inheritance, encapsulation, and abstraction. And this is just a very brief overview of what OOP concepts are about. We'll cover them in detail as we'll move forward. Now, this slide talks about, I read it, because using classes well requires some upfront planning, they tend to be of more interest to people who work in strategic mode, doing long-term product development, than to people who work in tactical mode where time is in very short supply. Now, when you're using classes, you have to do a whole lot of planning and designing, and this development is for long term. And classes come into picture mostly are used in such projects. Now, the concept of self you were asking, like yesterday when we were discussing one of the classes, we were writing some code where the class had come. You were talking of self. In Java, you must have heard of this pointer, right?
Yeah.
So self is like this only, except that uh, when we write, this is a class C1, which has a method set name, and it assigns this set name, assigns an attribute to the class, the object, instance object of the class, an attribute called name, which is set to incoming parameter of who. Now, when we do I1, an instance of C1, this self refers to I1 for this in this line and self refers to I2 when this line executes, and this would print Bob because I1 is setting name equals to Bob. Now, this is a very basic structure of how we define classes. It is not a very good
But why are we using self? What is the advantage?
self is supposed to be
What's the
used.
requirement of using self? So see, we have instance, we are using L1 as an instance of C1 class, okay? And we have provided Bob, okay?
Okay.
Yeah, in class C1, we are providing two instances, C1 and C2, self
C2,
and
C2 and
who.
C3. Yeah. So
Sorry,
this,
yeah, C2, C3.
so when C1, the way to read this piece of code is that C1 has parents. C2 and C3 are parents of C1. So C1 is inheriting from C2, C3. Superclasses of a class are passed as an argument to the base class or child class, to the child class as parameters, as arguments. So whenever you see something like of this sort, where a class keyword is there, then class name is there, and there are two other class names are present in the parentheses, that means those classes which are in parentheses are your parents class, super classes, and C1 is the child class of C2, C3. This is the relationship between these three. And you might have heard of that in Java, we cannot inherit from two classes. We have multi-level.
Yeah, these interfaces.
Yeah, so we have multi-level inheritance in Java, but in Python, you can inherit from multiple classes.
Okay.
And when you
So the problem of ambiguity is not here in Python.
problem of
Ambiguity.
ambiguity, yeah, you're right. Let's say some function name is there and some function definition is provided by both C2 and C3, which has got the common name. Now, how that ambiguity will be resolved, we can check. Just a second. we need to do some programming over here to check that, to clear our doubt about it. Class C2 def display equals to print C2. Okay, class C3 def display print C3. Now class C1 C2 comma C3 what should we say? Def
Define a function.
call display. Well, we don't need to do that. I think that pass will also work. Pass is, you aware of pass?
It will just pass.
Like a null statement. Okay, so C1 is like this class, then we would need to do I1 equals to C1 and I1 dot display. Okay, there is an error because whenever the error we made of is this, that we didn't pass self to display. So we'll copy it. So self will always come as a language rule of the language. If you are defining a class and that class has some methods in it, then first first argument has to be your self. I think now it would work. Always, yes.
Always, or just at least in one function, or it is always?
No, always. Yes, because I think that we saw that error, right? This error, display takes 0 positional arguments, but 1 was given. I think we did not pass any arguments to this. This is an important, just one, it says one argument was given, but as you can see over here.
What if it is not binary?
Sorry, I didn't hear you.
Yeah, we just try to run.
Yes. So print C2 self, C1 pass display.
Check the pass also if it is correct or not. The placement. Class C1 pass.
Are you saying something without self? So I just try to run it. Exit cd OneDrive cd desktop dir slash p python script.py c2. So what is happening? You got it? We called the display method. Without self, we were getting this error. So self is required all the time. Whenever you are defining a function in a class, self is always required, and it was supposed to have the ambiguity problem. Now we can also define a class C0 where we do this and we call it pass. Then this would I0, C0, I0, C3. So basically precedence checks in case of ambiguity. It resolves by checking the order of the classes. Got it?
Okay. So the class we are giving first in the parameter argument list, it will take that.
Yes, yes.
Okay.
So this code is clear, right?
So I think in Java it used to throw an error. Correct?
Yes, yes. In Java, it would throw an error. We can check. Shelby, what error it
No,
throws.
it's okay. So in Java there are interfaces, right? We implement the
Yeah.
functions. Correct. I don't remember correctly.
So in
Okay.
interfaces is there. It's like a signature, like what would happen, what is expected from a class, or what is expected from a class. It's like a contract that whenever a class inherits an interface, it has to implement the methods of that interface.
So in Java for multi-level or multiple,
Just multiple.
Yeah, multiple inheritance, we have the interface just for multiple inheritance.
Yes, yes.
This idea came up for multiple. Okay,
Yes,
okay.
yes.
Okay, now in this example, we have C1 class which inherits C2 and C3.
Yes.
This is sorry, inherited from C2 and C3.
Yes, yes.
Okay, we have defined self. Okay. What if we try two function without and second function is without self? Will it throw an error? The script only. Suppose we define two functions, display and display one. And in display one, we don't define, we do not provide self argument. Can we try that?
Okay.
Just define one more function. Define display one without self. Yeah, and now call C2.
Now, what we would have to do. But we would have to call also, right? I1. Or either one can do it
C2.
basically.
Object of C2.
Object of C. You are asking me to create an object of.
No, C1 is already okay. It will work.
It will work, right? I0 dot display.
C1 will work. No need to. We have already declared I1 is equal to C1. No, just put I1 dot display 2. Yeah, that's fine.
I think that this is giving an error. 1 second. So whenever we do not define self, okay. So here is the thing we learn from it. I recollect. It says type error, right? It says type error, and it was expecting zero positional argument.
Did you run it? I couldn't see. Did you just run it?
Yeah. Shall I hit enter if you're seeing my screen?
Yes. Yeah, just. Okay.
So I'd explain the
Yeah.
error. Just a second. When you
Type
were,
error.
yeah. So you know that in Python we are always supposed to give self. Is that you aware of that? Now let's say yes,
Now
your
I
answer.
am clear. No, I was not aware of that.
So yes. Now there
Okay.
is one more thing to know. Python assumed
Mhm.
that whenever you're calling the function of a class, whenever this I1 is a class, right? And an
Mhm.
instance of C1, then whenever you are calling display2, it automatically passes self. Why? Because it is written over here. One was given, isn't it? But we have not passed any. That means something is being passed explicitly behind the hood, under the hood, right?
Mhm.
So that one parameter which it says was given to display2 was self only. Getting my point?
Okay, we automatically provide self,
Self,
but
yes.
it was not.
It was not there
But
in
it
the
should be
definitive.
declared in the function also.
Yes, it should be declared in the function also. Otherwise, you are seeing the error which you are seeing. If there is no mismatch, self is there, then one positional argument is expected and one was given explicitly or implicitly, which is self. Whenever we are making
Okay.
calls like these, right? One argument is always present,
Mhm.
even though we are not seeing it. Self is kind of this, or self is always passed. An instance of I1 is passed for display 2 to work.
Mhm.
Got it?
Mhm.
So
Okay.
okay, this is clear, this slide.
Yes.
Okay, now we move on to the next slide. Operator overloading. Earlier what we were doing was we did not have init. We only had some kind of functions, and we were calling them, making calls to the functions we defined in the parent classes C2 and C3, and from there we were making the calls and those methods got called. Now in this piece of code which we're seeing on the screen, you have an init method. You have an init method, and uh, this is a constructor. This acts like a constructor. Getting my point?
Mhm.
So
Mhm.
who, again, like we were seeing earlier, set name was there, I believe. Set name, right? Instead of set name, we change it to init, and rest everything remains the same. But now what happens is that you do not have to call init when you are going to be declaring creating an object of C1. If you pass, like, we can also try this code out. What would happen if we don't pass it a name? Let me just check that also. Shall I? Like over here, who is
Yeah.
given, right? What if we don't pass it? Would it take empty string? Would it create an error? I'm trying to check that. Is it okay?
Yeah.
Okay, 1 second. Script to Python. Script to What happens if we I3 equals to C1? Print I3 dot name. But what about C2, C3? We can just ignore them and say pass. Now, if we are script 2 is there, Python script 2, invalid syntax, something is wrong. How come it's set to Bob? Comments are in green, right?
Hmm.
So, okay. Done. Who? It will generate an error. It won't run without the third parameter. It will print Bob like it
One
says.
second, what we are doing here? Missing one required positional argument who goes to C1. C1.
So as expected, if who is required by the constructor, if constructor says I need a parameter, I need to know who this class is, what is the name of this class, then if we try to instantiate an object of class C1 without giving it a name, without giving it a name, then it will
Without providing the argument
yes,
parameter.
yes. So it will
Okay. And what does both that operator wala slide? Copy or operator? Operator overloading. This is different, right? What's the concept? I1, C1 Bob, I2, C1 so. So I1 dot name, it should be Bob.
yes. Yes.
So what exactly? If print I2 dot I2 dot name, then it will be Sue. So what's the
Nothing, it's just teaching you how to use a constructor. It just says that earlier we were not doing like this, right? We were using set name in this thing, like set name I1 C1, and then set name was called. Now we don't need to write. Yeah, am I audible?
Again, the voice is breaking.
So okay, I'll speak slowly. Over here we had to write 1 and 2 lines of code, 4 lines of code, right?
No, it's the internet actually.
Okay.
Hello?
Yeah, am I audible?
Yes.
So 1 second. Let me know if voice breaks
Yeah,
again.
it's clear.
So over here
Okay.
we had to write 4 statements, right? To set the variable name to who. We needed 4 statements for I1, I2. But over here we only need 2. We only need 2 because we have defined set.name equals to who in a constructor, and that constructor method is this constructor method is underscore underscore init underscore underscore system level.
Yeah, this is actually clear.
Clear? Shall I move on to the next slide?
Yeah. Yes.
Okay, polymorphism and classes. So this example over here is of employee. We have employees working in a company, and some of them might be engineers, some of them might not, might be these security staff, let's say. So if we have an employee class and we have methods such as compute salary, give raise, promote, retire, then what would happen if we have then what do we do about an engineer, because his salary is supposed to be higher than the general employee, any employee, then basic level employee like JL2 or something like that. So we define a compute salary for engineer separately, and we write custom code over here. So compute salary is also an employee, compute salary is also an engineer, which is a child class of employee. Now, when we do this, Bob equals to employee, Sue equals to employee, and Tom equals to engineer. And then we try to run this piece of code, we would be able to see that for Tom, who is an engineer, compute salary would give a different result. If you want, we can try it in code also. Okay, 1 second. Let me just copy it. It is a matter of seconds. Script 3 by employee compute salary pass, and then we will write this salary print engineer. Here, then we would do like this, and then this. Bob, Sue, Tom, employee in company, and then well, we can use list comprehension as well. This won't give us the result because we are not returning anything, we are simply printing. So this would not differ for any of the classes, either engineer or employee. But what we can do,
So it should return employee, and engineer, right? Employee,
this
engineer.
Yeah,
Yeah.
there will be, so like print is calling, so it would print it, not exactly what you were saying, but a better version to check it would be something like this: for emp in emp dot compute salary, instead of printing, right? Because what is print doing? This call compute salary is not returning anything, so we'll run it anyway because this line is
So
also
while
there.
printing, we can simply call just emp dot compute salary. For emp in company, no, we are using print. Why are we using print? We can simply call emp
Yes,
dot compute
yes,
salary, right?
yes. So this is, yes,
Now
you're
it
right.
will give output as employee, engineer.
Employee engineer, yes. Let's try it.
There is just one more bracket you need to remove from compute salary
Okay, yes.
in the for loop.
Yes, that clear. Done. Step 3. Employee engineer as expected. Good to go.